Hi, very good morning to you. It's Jim from maverickstar Observatory. Okay, so a couple of things we want to go through today. Obviously, we're going to be talking about what's on the Learning Centre of the website, poleshiftnews.com, and we're just going to go over some of the things that we know about the Earth's magnetic field and how we know it goes through reversal and how we measure the time periods in between reversals. But before we do, as usual, super big thank you to Alex. It is amazing what a few people can do when giving a bit of support for this observatory. It really can carry us, and Alex was one of those guys, as well as a couple of others the other day, that chipped in. And it's well worth mentioning when somebody does something a little bit more normal than others, to just give them credit for that help and support. So big thanks, Alex, and for everyone else that is supporting what we're doing here. This is a topic that really is happening at the end of the day. We are the first of any intelligent species on this planet to go through a magnetic reversal, and the reason why I say that is because of two things. One, we have only been on this planet for 42,000 years as Homo sapiens, and two, the last time the Earth went through a magnetic reversal is, as many of you know now that follow the channel, 780,000 years. So with that, I just wanted to go over a few basics so that we get an understanding of a few fundamentals about Earth's planets going through magnetic reversals. Before we do that, yesterday I brought it to your attention that we got our piece of equipment that measures the atmospheric oxygen content out, and we took a sample rate of that, and it came back low. I think it was about 3% short of what it should be. So investigating that a little bit, I was about to do a chemical test, and you've probably seen me do that before, where we get a small amount of wire wool, soak it in some mild vinegar because it's acidic, and we stuff that into a modulated test tube which has got increments on it so we can measure what's going on, and it's been specially adapted so that when you place it in a bath of water, a small bath of water, there's a tiny little hole which allows the water to leak in to the point of the first modulation on the tube, which is at the 10. And by putting the acid on the wire wool, what happens is it starts to corrode, and as you know, corrosion on iron is iron oxide, so it removes the oxygen out of the tube in the form of iron oxide, and it causes a drawing effect of the water to go up the the tube, and we can work out how much of the air in the tube was there, or how much of the oxygen was in the tube when the reaction has gone through a completion, or the wire wool has absorbed as much as the oxygen in there. So we've got two ways of doing it. The laboratory way, which I've just explained, or we can use one of these state-of-the-art Luminox sensors. And I was doubting that something was wrong today when I looked at the oxygen sensor, because when I switched it on, it was reading inside the home 15%, or just over 15%. I knew that was wrong. I just knew that was wrong. So I thought, okay, maybe the battery's flat in the unit, and I should have checked that yesterday. And lo and behold, put a new battery in there, switched it on, and it took a reading in my living room of 20.51. So it wasn't the fact that we got a low atmospheric reading of oxygen, it was the fact that the battery had gone flat. The other thing I noticed, because it also the atmospheric oxygen sensor's got a barometric pressure reading on there, it's also got a temperature reading. I noticed those two, which I don't usually pay any attention to, were also reading strange anomalies in their readings, and I thought to myself, yeah, we cracked it anyhow. So we didn't have a problem with the oxygen yesterday. So let's move on with just some fundamentals about how we know the Earth goes through a magnetic reversal. So in studying of the Midatlantic Ridge, we find that the natural rock formation has solidified magnetite in one direction, But when we have a reversal, it goes into the other direction. And as you can see in this little image, you can see that we have like stripes at either side of the Midatlantic Ridge, or where the magma is coming up out of the mantle into the surface at the bottom of the sea. And what's happening is it's pushing up and over periods of time. You'll get these bandings, and we can work out from the time it takes to move, say, I don't know, 2 foot. We can measure how long it took to get to 2 foot, and then we can just measure the whole band by sending probably a magnetometer down there, being towed over a long region of the one half of the the ridge. We can find out exactly how long each reversal has lasted before the next time it's gone through a reversal. So that's how we know how the Earth goes through a reversal, and it gives us an idea as to how long a period of time it was before it went through that reversal. And that's how we know it was around 780,000 years ago when the Earth had last gone through its reversal. We live in really unique times right now, because we are simply going through a reversal right now. At this point, we are moving to a time in the near future where things are going to start to dramatically change. I mean, you can go on to this Pole Shift News if you want to read some of the stuff I've put up there, just to give you an idea in the learning section. So if you go to the others on the website, you'll scroll down and you'll find the learning centre. So you can see what the Earth looks like here between reversals, and you can see what happens during a reversal, and you get multiple poles. And we've got multiple poles on the planet right now, and not a lot of people know that. We've got 4 magnetic poles. The one in the southern hemisphere of the Earth, not the one that is merging over Australia at the moment, but the other side, to the left hand side of that, we've got probably one of the weakest magnetic poles there in that region. One of the strongest magnetic poles, and is increasing in magnetic field strength, is over Russia. But one of the largest ones we've got is that one that's crept over Australia, or is going close to the south coast of Australia. So we know what happens when the Earth goes through a reversal. The 2 main poles split apart, and we will see this happening at a later date on our Earth. There will be multiple poles just before we go into a complete reversal, and I believe we could start to see more than the 4 poles that we've got, even more than that, form when we get past that 40-degree mark. Because what will happen is that the Earth at the moment is still holding on to the magnetic North Pole because it's in the strong field lines, but as soon as it leaves those strong field lines, it will migrate into the weaker field lines, and things are going to pick up from there. And you might be asking yourself, what sort of things can we expect during a reversal? Well, I think we're already witnessing some of these things when we look at the climate on the planet over the last 30 years. And it's because I mentioned 30 years is because if we see dramatic changes taking place in those last 30 years, and we also see dramatic changes in the speed of the migration of the magnetic North Pole, then I think it is perfectly normal to assume that those two are related. We just have to find the connection, and I believe that we're already there. I think the connection is to do with the jet streams and the weakened magnetosphere, which is suggestedly 15 to 20% weaker than what it was years ago. So what has happened is the poles have weakened, more cosmic rays have been inbound, which has allowed cloud to seed in the jet streams, creating a sluggish, slow moving jet stream that fractures. And then when you get the fracturing take place, you get interchange between the subtropical and polar jet streams, and that's why we have these flash points of dramatic change. One day it could be plus 20 degrees, the next day we're back down to 0. and that is also probably the reason for, you know, these dramatic floods that we seem to be having on the increase now, and droughts in other parts of the world. I just wanted to go over some of the components of the magnetosphere. As you can see here, we've got the magnetosheath, the magnetopause, the cusp, the plasmasphere, and the neutral point. What I want to just bring to your attention is, if you look by the magnetopause, we've got the cusp. Now, this could lead to seasonal changes for us, because we are at an angle of about 20 something or so, I can't remember off the top of my head. I think it's 21 or 23 degrees, and you know, our Earth doesn't, like some people think, flip from one side to the other. It's just the you know, when we're going around the sun, it goes from, you know, we could be over the northern hemisphere, over in the in the northern hemisphere we could be in the summer as it's at one point, and then when it goes 180 degrees to the other side of the sun, we'll be further away. That's what gives us our seasons. But you'll note that the cusp is at an angle which will allow more radiation inbound at the northern hemisphere when it's at one side of the sun, and then at the southern hemisphere when it's at the other. And you know, the cusp is probably the weak spot in the entire magnetosphere, because that's where some radiation creeps in more at more points of the Earth than others. But at least you get an idea. There's a lot of components that make up the magnetosphere, and you know, without this magnetosphere, our planet's water, atmosphere, and of course all the biodiversity of life would not simply exist without the magnetosphere. And it is the magnetosphere that gets majorly disrupted during a magnetic reversal. As you can imagine, if there are multiple poles, it's obviously not going to form a true magnetic north and a south, and therefore it is going to probably create more problems and longer term problems, just like the cusp does right now at a 20% reduction already in the magnetosphere. I think it's important just to mention the large amount of people right now that are completely unaware that there is a pole shift taking place and its implications. You know, it's around 98% of the population of human beings on this planet that are completely unaware, and of course all the other biodiversities will be unaware as well, but they will obviously be showing signs of these changes when the climate starts to change. One of the things that we can immediately look for is, like, you know, trees and other plants that we've imported into some of the northerly latitudes of our planet. They shouldn't naturally exist here, and as the climate starts to cool, you'll notice that these species are going to be the ones that suffer. You might have noticed some trees in the last 5 years that are doing terrible. You know, they're late at putting their bud burst out into leaves, and some of the plants just die. So some of the things that you can look out for there. You know, I haven't made nothing up about this magnetic pole shift. This is all verified by, you know, well-known organisations, and you know, I just think it's a bit disappointed that they don't talk about it too much. And you know, you've only got to ask the question, why is that? Well, it could be that this is probably one of the most serious anomalies that we are facing and going through right now, and I think it's well worth our observatory, you know, doing as much as we can and filling the gaps that these bigger organisations don't fill. And I think we've done a great job. Sometimes, as you guys know, as you've been following me, just before they updated the World Magnetic Model Map, we told people that there had been some dramatic changes, and weeks later there was that announcement of the organisations having to update their magnetic models. We come to the table with the information and told you guys well before these big organisations did, and I would love to do that time and time again. I think we've done it a couple of times now. So the other things that we've got on the Learning Centre are some really great videos that explains a little bit more about how important, you know, magnetic poles are, the dynamo, the magnetosphere is to planets that sustain life, also atmospheres and oceans, because without the water on our planet there simply wouldn't be any life. Without the magnetosphere there simply wouldn't be any life, even if there was oceans on there. But because if we remove the magnetosphere, we then subject it to sputtering. And NASA themselves have done this video here, Martian atmosphere loss explained by NASA, and how that takes place. Well, simply the solar radiation would strip off the upper atmosphere, leaving all the water and biodiversities exposed, and then there would be a slow sterilization of any life on the Earth by that radiation, and then we would probably see a reduction taking place in the oceans themselves, as what has happened to Mars. But yeah, there's some good videos. This one was removed. It was a video done by Nova. You might be able to find it on YouTube, or it might have been completely removed, but it explains exactly what I've been explaining for years. Another good video is this one here, because we know the sunspots aren't working according to how NASA tell us these days. We're supposed to be just coming into the beginning of solar cycle 25, and that is arguable. But the sunspots should be equatorial in a minimum, and not where they are right now at around about 30 degrees. And you can check that yourself very simply by coming on to our solar observation point in this pole shift news, and we've got some widgets on there which give you that live information on the solar disk. Just ask that question: why are the sunspots not where NASA are telling us, when these are the experts? And let's face it, you don't need spacecraft to see these sunspots and where they are located on the sun, because if you've got a good welding mask on a bright day, you'll be able to look up there and see them yourself. I wouldn't advise that you do it with your naked eye, but and I think it'd probably be impossible anyhow with your naked eye to see sunspots unless there was enormous. But we can check things like this ourselves. We don't need to rely on NASA. But what we need to ask is, when NASA are telling us, at solar maximum, sunspots should be at 30 degrees north and 30 degrees south, and it's not, we have to ask the question why that is. Another good video here, hazards of geomagnetic storms. Well, if the magnetosphere collapses, you might want to watch that, because that will tell you exactly what will happen if we do with regards to geomagnetic storms. Again, sputtering is a term that NASA use, and that is a term where it describes the radiation stripping off the upper atmosphere. All these things we talk about on this channel are correct. Sometimes we're good enough to come out with the information before these big organisations. Obviously NASA have never explained why sunspots are at 30 degrees north during a minimum, when they put this video out there which contradicts what they say. Maybe someone should just mention that to them, when they are supposed to be, after all, the experts of space exploratory, and they have obviously something wrong here. And it's not like these big organisations don't get things wrong, because they do. If you remember when they first put out the the updated magnetic model, they'd got the legends wrong on the bottom. And it was because I mentioned it on here that one of my subscribers went to NOAA, told them about it, and then they corrected it. So, we do a service here sometimes, more than what we should do, because we don't get the funding like NASA does, that's for sure. But you know me, I'm very resourceful, and what funding I do get, I make it go as far as possible. And that's why today we've got tracking equipment, the Trimax system, which tracks the movement of the magnetic pole at a resolution of 3 seconds, 24 hours a day, 365 days a week. We've also got other equipment that is bespoke to our observatory, like the muon detectors, background radiation, Geiger counters, and CO2 meters, as well as, if we struggle to use technology, we've also got the knowledge of me being a scientist, and sometimes I can come to the rescue with an alternative method of finding out that information. So we've got a good machine going, and we've been successful enough to this point, but it's largely down to people like Alex and a few others, not to keep mentioning names, but you know, these are really the superstars that keep this observatory going and allowing me to inform you. The other thing is, I will just say this: we used to get 7,000 views on the website. We're now getting 10,000 views a week. But you know, it is only a couple of people that click that donate link on there, and that's why sometimes I miss if somebody's donated, because I don't look at it that much. We get more on the YouTube link that we've got for the PayPal than we do on that, and yet we get more views on the website than we do on PayPal. Not on PayPal. More than we do on YouTube, which is a bit of a mystery. I mean, it might be just the fact that, you know, people find it more convenient to click that link down there in the description than they do to go over to the website and then click it. So it doesn't really matter, but you know, there is a lot of people using the service and the information that we've got on the website. Just be great if a few more people would step up. And I think we're starting to just attract a few more people that are prepared to regularly, you know, subscribe to us. And not only, which has been dormant for a long time, we haven't had really much activity in the subscribers, but it is creeping up noticeably now. And you know, we are starting to see, hopefully this is a sign of improvement, a couple more people, you know, pledging a bit of support for the observatory. And you know, if you guys want to help support what we do and all our efforts in getting this information to you, there's a link down there in the description. It's as simple as that. Guys, I won't keep any more of your time. I'll just say what I usually do at this point of the video. If you want to support us, there's a link there. Take care of your loved ones, and I'll say what I usually do. Bye for now.